All right, this video is going to go through the 5-8 lesson opener first, and then it's going to get you to the 5-8 notes. So today we're going to talk more about scientific notation. So just a quick reminder, take a look at this slide right here, and think about the ones that are in scientific notation and are not in scientific notation, and see if you can just kind of put your eyes on some that are not in scientific notation. So you should hopefully have pointed out that this purple one here, 600 times 10 to the 7th, is not in scientific notation. 150 times 10 to the negative 6 is not in scientific notation. And this 0.234 times 10 to the 8th is not in scientific notation. Same with this red one here. These are not in scientific notation. And the reason that they're not in scientific notation is because the first number is not a number between 1 and 10. So remember, the number that's before the 10 should be like a number like 6.0 or 2.3 or 5.0 or 1.5. So these are not in scientific notation. The other ones are in scientific notation. Which brings me to, what would I do with the ones that are not in scientific notation? It's actually pretty simple to do. So if you take a look at this first problem here, 6,400 times 10 to the negative 8th, that's technically not in scientific notation because the 6,400 is too big. It needs to be a number between 1 and 10 and could be equal to 1. So what you can do to convert this into scientific notation is start first by looking at the very first number. So we're going to ignore the 10 to the negative 8 for just a moment. And we're going to take 6,400. We're going to put that in scientific notation. So if you think about that, that's 6.4 times 10 to the third because we're moving the decimal point back 3 places. But then we're now going to bring back that times 10 to the negative 8th. So when I do that, we now can follow our powers of our exponent rules. Because these have the same base, all you have to do is add the exponents. So 6.4 times 10 to the negative 5th is actually equivalent to 6,400 times 10 to the negative 8th. So we can do the same thing for the next one. The next one's not in scientific notation because this first number right here has to be 7.5. So we're going to change 0.75 to 7.5 times 10 to the negative first, because remember 0.75 is a small number. We moved the decimal point to the right one time, so the exponent on that would be negative 1. So if you think about it, 7.5 times 10 to the negative first times 10 to the negative 25th, these have the same base, so you can add the exponents, leaving me with 7.5 times 10 to the negative 26th. All right, try the next one. This one, negative 300, the decimal point's not in the right spot, so we need to move it in between the 3 and the 0 to make it negative 3.0 times 10 to the second, because negative 300, the number 300, the absolute value of negative 300 is 300. That's a big number, so that's going to have a positive exponent on it. We're then going to take that negative 3 times 10 to the second, and we're going to multiply that by the 10 to the 17th. These guys have the same base, so that's going to give me negative 3 times 10 to the negative 19th. The next one, this guy right here, needs to be in scientific notation, so that's negative 7.0 times 10 to the negative second, because we have to move it to the right 2 places. So we're going to take that negative 7 times 10 to the negative second. We're going to multiply that by 10 to the 52nd. And because these two have the same base, we can add the exponents. So my final answer is 7.0 times 10 to the negative 54th. So let's go ahead and take a look at these two problems. So looking at these two problems, the one on the left, you definitely know how to do, right? We just multiply negative 4 times 12, giving us negative 48. And then m to the third and m to the 15th, they have the same base. So you can add the exponents, giving you m to the 18th. So think about that. That rule, it absolutely can apply to scientific notation, right? So if you take a look at the scientific notation problems, if I'm trying to multiply two things that are in scientific notation, I can just go ahead and follow my exponent rules, right? Because multiplication is commutative. You can do them in any order. So I can go ahead and multiply negative 4 times 12 together, leaving me with negative 48. And then the 10 to the third times 10 to the 15th, we can put those together, leaving me with 10 to the 19th. Now, this answer, not in scientific notation. The reason it's not in scientific notation is because negative 48, the absolute value of that, is too big. So I need to adjust it. I need to put the decimal point between the 4 and the 8, just like we did before. So this number in scientific notation is negative 4.8 times 10 to the first power. And then we're going to multiply that by 10 to the 19th power. So what I'm left with is negative 4.8 times 10 to the 20th power. And that's how you do that problem. Now consider these two problems. Negative 2n to the third over 8n to the ninth. Now what we would typically do is we would simplify this, right? So negative 2/8 does reduce to negative 1/4, and n to the third over n to the ninth. We're canceling out the 3 n's on the top, leaving us with 6 n's on the bottom. So that would be this answer in simplified form. However, what if I said, can you make this just all on one line? So essentially, technically what we could do is negative 1/4, remember, is the decimal 0.25. So we could just divide to negative 2 and 8 and get negative 0.25. And then we also could just subtract our exponents. 3 minus 9 is n to the negative 6th. Both of these things are equal to each other, but the simplest form with just problems that look like this would be the fraction form. The reason I'm showing you this is because the same rule applies when you are doing scientific notation, when you're dividing scientific notation. So this division problem, essentially, all we're doing is 2 divided by 8, negative 2 divided by 8. And if you think about that, that's negative 1/4, which is negative 0.25. And then you just subtract your exponents, 3 minus 6. So we're subtracting these, leaving us with negative 6. Now that technically is not in scientific notation because where does the decimal point need to go? It needs to go between the 2 and the 5. So I would rewrite this as negative 2.5 times 10 to the negative first power, because 0.25 is a small number. Small numbers have negative exponents. Then you would multiply that by 10 to the negative 6, add those exponents, and you would get negative 2.5 times 10 to the negative 5th. Now, consider these two problems. If I'm simplifying 6y to the 5th to the third power, I'm taking that whole thing to the third power. So essentially what I'm doing is 6 to the third power, and you multiply your exponents. So 6 to the third power is 216. Y to the 5th to the third is y to the 15th power. We apply that same rule to scientific notation, right? If I'm going to bring that 3 in, I'm essentially just doing 6 to the third power, which is 216, times 10. If I'm doing times 10 to the 5th, that whole thing to the third power, that's going to give me 10 to the 15th. But that's not in scientific notation, right? 216 is 2.16 times 10 to the second, because we would need to move the decimal point back. So essentially we would add 2 to the 15th. So we would get 2.16 times 10 to the 17th. All right, now we are going to start the 5-8 notes. And so what I would like you to do is find your notes and fill this in with me, Or you can stop the video and fill this portion in yourself and then come back and see if you have done them correctly. Okay, but basically these first four problems are basically just asking you to adjust them, put them into scientific notation. Reminder, the reason that they're non-scientific notation is because the first number is not between 1 and 10. Okay, so just a reminder, like we did before, 7,000 in scientific notation is going to be 7.0 times 10 to the third power, but we're multiplying that times 10 to the sixth power. We combine the exponents on the 10, leaving us with 7.0 times 10 to the ninth power. So essentially, this we're moving back 3 places, so we would essentially add 3 to the sixth. So 250, we have to move that decimal point back 2 places, so that's going to leave us with 2.5 times 10 to the second power, but we're adding on times 10 to the negative 18th. So you add the exponents. This gives you 2.5 times 10 to the negative 16th, because 2 plus negative 18 is negative 16. All right, the next problem, we are actually moving the decimal point in the other direction. 0.004 is a small number, and it's too small to be in scientific notation, so I got to move the decimal point so it's after the 4, and I'm moving it 3 places, so that's going to be 4.0 times 10 to the negative third power, and then we're going to multiply that by times 10 to the negative 21st power, combine the exponents, and you get 4.0 times 10 to the negative 24th power. And then number 4, you're moving it to the right 1 place, so you get 3.0 times 10 to the negative first power, because we're moving it to the right. 0.3 is a small number, negative exponent, times 10 to the 50th, we're tacking on, leaving us with 3 times 10 to the 49th power. Okay, so essentially, when you're adjusting this, when you move your exponent, when you move your decimal point to the right, you're actually subtracting. So here I just subtracted 1. Here I subtracted 3. Here I moved to the left, I added 2. Move to the left, you add 3. It's another way of looking at it. So now we're going to go ahead and figure out how do I do operations in scientific notation. So remember, we're using our exponent rule. So the first one is just all multiplication, right? So we just multiply the negative 1.6 times 4 together, and negative 1.6 times negative 4 is just negative 6.4. Remember, that's like 16 times 4, but we move the decimal point back 1 place because it's 1.6. So we multiply those, and then we put together the 10 to the 8th and 10 to the negative 12th. So we add the exponents. 8 and negative 12 gives me negative 4. So we have times 10 to the negative 4th. And then we ask ourselves, is that in scientific notation? If it is, then we are finished. If it is not, then we have to adjust it. So then the next one, raising a power to a power. All I'm doing is I'm taking negative 2.5 to the second power, and then I'm taking 10 to the 8th to the second power. So negative 2.5 times negative 2.5 is the same as doing 25 times 25, except we've got 0.5 and 0.5, so we move our decimal point back 2 places. So that is going to give me positive 6.25 times 10, and then 10 to the 8th to the second. You just multiply your exponents, which is 16. That answer is in scientific notation, so we are finished. Number 7, we divide. Okay, so you always put scientific notation in one line. So you're allowed decimals and you are allowed negative exponents. You're not allowed that anywhere else except for scientific notation. Okay, so looking at this, 2 divided by 8. Essentially, you're doing 2 divided by 8. You could get out a calculator and get this, or you could do this in your head. 2/8 reduces to 1/4, and 1/4 is the decimal 0.25. Many of you know that, okay? Then you take your exponents here and you subtract them, okay? So here we divide and then our exponents we subtract, okay? 4 minus 11 is -7. So you get 10 to the -7th. Now, this is not in scientific notation, so we are going to adjust it, okay? So we need to move this decimal point to the right 1 to make it 2.5. And because that's going to be 2.5 times 10 to the -1st, we're combining -7 and -1, leaving me with 10 to the -8th. If you want, you can go to Desmos and type these problems in, and a lot of times Desmos will give you the answer in scientific notation, so you can double check to see if they're correct. Now take a look at the next 3 problems. These are for you to try on your own. So I absolutely want you to stop the video. Then when you're done with the problems, come back, look at the video, and see if you've got the correct answers. So you should have gotten these answers. I went ahead and tried to give you some hints as to what to do. For number 10, if you didn't get 3, remember you're doing -4 minus -7, which is the same as -4 plus 7. If you got any of these wrong, make yourself a little note. Make sure you ask me about it when you come to class. Now, go ahead and look at these 2 problems and see if you can find the mistake and correct it. So again, stop the video, do them, come back to see if you did them correctly. All right, so I went ahead and corrected them. For the first one, they forgot to take 2 to the 4th power, which is going to give us 16. Then you have to adjust it by moving the decimal point back 1 and adding 1 to the 48. For the second one, they just subtract it incorrectly. 12 minus -5 is the same as 12 plus 5, which does give me 17, not 7. All right, go ahead and start your CYU.